Hi, today I'm going to show you how I connected my Arduino Nano onto my HC05 Bluetooth module via a voltage logic level converter. What I'll do is I'll put a schematic on screen for how I've wired this circuit, and I'll quickly get into explaining the purpose of the logic level converter here. Basically, the Arduino Nano uses a 5-volt logic levels. This means that when it's transmitting data on the transmit and receive pins, it's doing so at a 5-volt logic levels. Now, the Bluetooth module needs to use a 3.3 volts logic level, as shown on the back here. It should tell you on the back of your device. The receive pin of the Bluetooth module needs 3.3 volts logic levels, and it needs between 3.6 and 6 volts power to function on the VCC. What I do is I use a logic level converter in between. This converts the 5-volt logic signal from the Arduino into 3.3 volts, which is compatible with the Bluetooth module. The voltage logic level converter works by it takes the 5 volts and the 3 volts from the Arduino to use as reference voltages, and it also needs a ground for both the high voltage and the low voltage inputs on the converter. And then once it's got those reference voltages, it can convert the voltages for the logic levels from 5 volts to 3.3 volts and vice versa. When your Bluetooth module is plugged in, you'll notice that it's got a rapid flashing light, but when you connect a Bluetooth device to the module, you'll notice that the light begins flashing much slower. This is simply so that you know when a device is connected to your Bluetooth module. Okay, so on the computer, I've got this simple sketch here. And this sketch uses the AltSoft serial library. If you don't have that already, you can go to Include Library, Manage Libraries, and search for, once it lets you, search for AltSoft serial, and then just click Install if you need to. Then you can upload the code onto the Arduino board. So I'm quickly going to go over what this code actually does. So it uses the AltSoft serial library. What this does is allows us to use pin number 8 and 9 as receive and transmit pins for the Bluetooth device. This way we don't have to use the default TX and RX pin on the Arduino device itself. It basically allows us to double up on the transmit and receive pins on the device. Okay, so in the main setup function, what we do is we define that we want the default built-in LED to act as an output so that we can control in our loop function. We also initialize the default serial so that we can monitor the messages that are coming in and going out, and we initialize the AltSoft serial library with a default baud rate of 9600. That's because my Bluetooth module uses this the baud rate of 9600. Other Bluetooth modules might use a different baud rate. It's worth investigating to find out, because if not, you won't receive messages, or if you do, they'll be all kind of scrambled and jumbled and you won't be able to make full sense of them. Within the main loop function, I check to see if there's any data available on the serial communications line. That'd be the main communications line via the serial monitor. I read that information and then I print that to the Bluetooth serial line, alt serial communications line. And then if there's any information available on the alt serial communications line, we will read that information, we will act on that information, and then we will print to the console and the Bluetooth device the same information, just so that the devices know that we've reacted to that information. So what we do here is we have a switch case statement. What this does is allows us to compare the character that's stored in the variable C, and if the character is number 1, we turn the built-in LED high. If it's number 2, we turn it low. What this does is basically when we send the number 1 to the Bluetooth module, it should turn the built-in LED on the Arduino Nano on, and when we send the number 2, it should turn it off. So what I'm going to do is use the S2 terminal for Bluetooth app on Android. If you don't have that, you can download it from the Play Store. Once I've got that app installed, what you want to do first is make sure that the Bluetooth module is paired to your Android device. If they haven't been paired, then S2 terminal won't be able to connect to the Bluetooth module. So first of all, pair your devices in your Android's Bluetooth device settings. Once the devices are paired, you will be able to connect to the device. You'll be able to connect to the Bluetooth module from your Android device, and you will be able to test and send information to it, providing you've already uploaded the code to the Arduino board and all the connections have been made properly. You should see that the LED on the Arduino Nano turns on when we send the number 1 and turns off when we send the number 2. If we send any other strings, it should just print that information back to us and not actually act on the message that it received. This approach is restricted in the fact that you can only read 1 character at a time. For example, what if we wanted to use the phrase off? We wouldn't be able to do that because we're only able to use 1 character at a time. In order to combat that, what I did is I wrote a more advanced sketch for Bluetooth on the Arduino. By default, I've set it up to perform similar functionality to my basic Bluetooth sketch over here. I will put a link down below to my GitHub with the code for these for anyone who wants them. But I'm not going to go into too much detail on the advanced Bluetooth. If you're interested in that, keep an eye out for my next video where I'll be connecting the Arduino and Bluetooth up to some WS2812B LED strips. So, if you liked this video and it helped you out, then feel free to hit that like button, hit subscribe and hit the notification bell so you don't miss any more videos from me in the future. Thanks, bye!